Welcome to another episode of our AI Spotlight Show teaching series. Happy Sunday to you guys. I'm here in Los Angeles and the time is 7:33 p.m. Pacific time. I'm actually at the airport, but this is a responsibility. I have to make sure I tune in so that we can engage in our AI teaching series. Okay, recently we concluded a 9 units model um, where we're able to establish an understanding of what is artificial intelligence, what is computer vision, what is responsible AI, and we also look at speech AI and we look at different use cases as well as scenarios of how these concepts are being leveraged or utilized or integrated into the real world. And today we want to kind of deep dive into the concept of machine learning, which is a subset of artificial intelligence. And if you are joining us for the first time, my name is Henry Onowale. I'm an AI expert, an AI specialist, an AI futurist, an AI strategist, and also an AI advisor. I'm also a responsible AI expert as well. If you're joining on LinkedIn, please endeavor to share. If you're on Twitch, also share. Facebook, YouTube, share. If you have any question, do not hesitate to drop it in the comment section. Okay, let's get started. Let's see what we have today. It's kind of sunny here, but I'll try as much as possible. Um, okay, machine learning is the basis for most modern artificial intelligence solution. A familiarity with the core concept on which machine learning is based is an important foundation for understanding AI. Then, what are the learning objectives? After completing this model, you'll be able to describe the core concept of machine learning. You'll be able to identify the different types of machine learning, and you'll be able to describe consideration for training and evaluating machine learning models. And you'll be able to describe core concept of deep learning and transformers. If you are new into artificial intelligence or you are aspiring to pursue a career in AI, it is important that you equip yourself with this foundational knowledge. It will help you to kind of have more insight how to navigate your way, in the AI world. When it comes to choosing a career in artificial intelligence, there are various fields, where you can develop interest in, depending on, the aspects that you're interested in. There is a technical side of the career and there is also a non-technical side. The non-technical side just implies that you might not be directly involved in implementing the technology, but you must have an adequate knowledge of the technology itself. To be honest, if you are not interested in learning technical things, I don't advise you to choose the non-technical side of the AI space. Yeah, because there is a lot of technical things that you need to know. You need to have that foundational knowledge of how it actually works. Although it's interesting, all you need to do is open your mind. Okay, what's the prerequisite for this model? Before starting this model, you should have a basic knowledge of mathematics and familiarity with Microsoft Azure and cloud computing. Yeah, these are important information. Our major focus right now is on the Microsoft Azure AI platform. And the reason why I decided to choose this based on my experience in the industry and what I've seen so far, a lot of organizations are using Microsoft's AI platform, even though some organizations also use Google product. But to be honest, in my own opinion, I believe Microsoft has a lot of customers than any other, uh, you know, providers. Yeah. Okay, let's deep dive into the introduction. The intro. Machine learning is in many ways the intersection of two disciplines, data science and software engineering. The goal of machine learning is to use data to create a predictive models that can be incorporated into a software application or on service. To achieve this goal requires collaboration between data scientists who explore and prepare the data before using it to train a machine learning model, and software developers who integrate the model into application where they are used to predict new data values, which means a process known as inferencing. In this model, you explore some of the core concepts on which machine learning is based, learn how to identify different kinds of machine learning models, and examine the ways in which machine learning models are trained and evaluated. Finally, we will learn how to use Microsoft Azure Machine Learning to train and deploy a machine learning model without needing to write any code. Wow, that is interesting. Let us read the notes. Machine learning is based on mathematical and statistical techniques, some of which are described at high level in this model. Don't worry if you are not a mathematical expert, though. The goal of the model is to help you gain an intuition of how machine learning works. We will keep the mathematics to minimum required to understand the core concepts. Okay, let's move to the next unit. What is machine learning? Please, if you have any question, do not hesitate to put it in the comment section. Okay, what is machine learning? Machine learning has its origin in statistics and mathematical modeling of data. The fundamental data of machine learning is to use data from past observations to predict known outcome or value. For example, the proprietor of an ice cream store might use an app that combines historical sales and weather record to predict how many ice cream they are likely to sell on a given day based on the weather forecast. Now, I can easily tell you what model was used to run this prediction. I can tell you it was regression model because you can use regression model definitely, to make prediction for weather forecast. Then the second example, a doctor might use clinical data from past patients to run automated tests that predict whether a new patient is at risk from diabetes based on factors like weight, blood glucose level, and other measurements. The third example, a researcher in the Antarctic might use past observation to automate the identification of different penguin species, such as Adelaide, Ginkgo, or chinstrap, based on measurement of a bird flippers, bill, and other physical attributes. Next, machine learning as a function. Because machine learning is based on mathematics and statistics, it is common to think about machine learning models in mathematical terms. Fundamentally, a machine learning model is a software application that encapsulates a function to calculate an output value based on one or more input values. The process of defining that function is known as training. After the function has been defined, you can use it to predict new values in a process called inferencing. I think that is a very simple, definition of explaining machine learning as a function. Just like um, if you're trying to train a model to learn how to predict if there will be an increase in the price of housing, maybe in 2035, all you need to do is to train the model with data of previous, house prices and other independent variable that might contribute to determine the price of housing, maybe depending on location. Then you can actually, when you have this data, you can train a model, to perform all of these prediction. Let us explore the steps involved in training and inferencing. Okay, this is exactly what I was saying. The training data consists of past observation in most cases. The observation includes the observed attributes or features of the thing being observed and the known value of the thing you want to train a model to predict, known as the label. That is exactly what I just said now. In mathematical terms, you often see the feature referred to using the shorthand variable named S and the label referred to as Y. Usually, an observation consists of multiple features value, so X is actually a vector, an array with multiple value like this, like x1, x2, x3. To make this cleaner, let's consider the example described previously. In the ice cream sales scenario, our goal is to train a model that can predict the number of ice cream sales based on the weather. The weather measurement of the day is temperature. You see, that is exactly what I was saying. When it comes to prediction, there are several factors that can be considered in, arriving at a prediction. It could be a combination of both dependent and independent variables here. The weather measurement for the day, we have temperature, rainfall, wind speed, and so on, would be the feature S, and the number of ice cream sold on which day would be the label Y. In the medical scenario, the goal is to predict whether or not a patient is at risk of diabetes based on their clinical measurements. The patient measurement, which comprises of the weight, blood, glucose level, and so on, are the feature X. And the likelihood of diabetes, for example, one for at a risk, one for not at risk, is the label Y. In the Antarctic research scenario, we want to predict the species of a pigeon based on its physical attributes. The key measurement of the pigeon, which means the length of his slipper, the width of his bill, and so on, are the feature S. And the species, for example, 0 for Adelaide and 1 for gentle or 2 for chinstrap, is the label Y. Point 2. An algorithm is applied to the data to try to determine a relationship between the feature and the label and generalize the relationship as a calculation that can be performed on X to calculate Y. The specific algorithm used to depend on the kind of predictive problem you're trying to solve. More about this later, but the basic principle is to try to feed the data to a function in which the value of the feature can be used to calculate the label. Point 3. The result of an algorithm is a model that encapsulates the calculation derived by the algorithm as a function. Let's call it F in mathematical notation, where Y is equal to F open bracket S and close bracket X. Then point 4. Now that the training phase is complete, the trained model can be used for inferencing. The model is essentially a software program that encapsulates the function produced by the training process. You can impute a set of feature value and receive as an output a prediction of the corresponding label. Because the output from the model is a prediction that was calculated by the function and not an observed value, you will often see the output from the function show as y, which is rather delightful, verbalized as y at. Okay, I believe this is clear. There are some certain things I would like to explain, but let us move with the reading of how the content is being curated. I don't want to be too fast, and I know this might be a bit technical for some of you guys who probably are not you're not doing maybe an engineering course, but trust me, this concept has been highly simplified, and all you need to do is to kind of pay attention and try to understand it. Yeah, I would definitely take my time to explain it in more understandable form. Okay, let's move to the next unit. Here we'll be talking about the types of machine learning. Okay, let's look at it. There are multiple types of machine learning, and you must apply the appropriate type depending on what you are trying to predict. A breakdown of common types of machine learning is shown in the following diagram. Machine learning, under it we have supervised machine learning, we have the unsupervised machine learning, and under the supervised we have regression and classification, and under the unsupervised learning we have the clustering. And under classification we have binary classification and multi-class classification. Now let us talk about what is supervised machine learning. Supervised machine learning is a general term for machine learning algorithm in which the training data include both feature value and known label value. Supervised machine learning is used to train models by determining a relationship between the features and label in past observation so that unknown label can be predicted for feature in future cases. I'm going to give us a quick homework to do. And my question goes this way. A fully autonomous vehicle of level 5, is it a typical example of a supervised machine learning or an unsupervised? This is a question. A typical autonomous vehicle level 5, is it a typical example of supervised machine learning or unsupervised? Put your answer in the comment section. Okay, let's move to the next. Regression. Regression is a form of supervised machine learning in which the label predicted by the model is a numeric value. For example, the number of ice cream sold on a given day based on the temperature, rainfall, and wind speed. Two, the selling price of a property based on the size in square feet, the number of bedrooms it contains, and socioeconomic metrics for its location. The fuel efficiency in miles per gallon of a car based on its engine size, weight, width, height, and length. Now, if you observe, regression is under supervised machine learning. Supervised machine learning definitely focus on data that are labeled. You can see now the label data, the number of ice cream. That means the data you want to use, they have been labeled, they are structured data. Yeah, supervised machine learning most of the time focus on structured data, labeled data. Those data are labeled. Okay, let's move to the next. Under the supervised machine learning, we have classification. Classification is a form of supervised machine learning in which the label represents a categorization or class. There are two common classification scenarios. One is the binary classification and the other is the multi-class classification. In binary classification, the label determines whether the observed item is or isn't an instance of a specific class. Or, put another way, binary classification model predicts one of two mutually exclusive outcomes. For example, one, whether a patient is at risk for diabetes based on clinical metrics like weight, age, blood glucose level, and so on. Whether a bank customer will default on a loan based on income, credit history, age, and other factors. Whether a mailing list customer will respond positively to a marketing offer based on demographic attributes and past purchases. In all of these examples, the model predicts a binary of true or false, positive or negative prediction for a single possible class. I think that is very, very clear. And and to me, if you are a statistics student, there's something they call an hypothesis. There is a false hypothesis. We have false hypothesis. We have a null hypothesis. An hypothesis can be true. It can also be null. Then it is either the hypothesis is accepted or the hypothesis is rejected. Multi-class classification. Multi-class classification extend binary classification to predict a level that represents one of multiple possible classes. For example, the species of a pigeon based on its physical measurements, the genre of a movie, which could be a comedy, horror, romance, adventure, or science fiction, based on its cast, director, and budget. In most scenarios that involve a known set of multiple classes, multi-class classification is used to predict mutually exclusive labels. For example, a pigeon can be both a gentle or an adele. However, there are also some algorithms that you can use to train multi-label classification model in which there may be more than one valid label for a single observation. For example, a movie could potentially be categorized as both science fiction and comedy. Okay, let's talk about unsupervised machine learning. Unsupervised machine learning involves training model using data that consists only to future values without any known label. As I said, the supervised machine learning focus on labeled data set. They are structured, but unsupervised could be structured or unstructured data. But most of the time, it's unstructured data because the data has not been labeled itself. Yeah, like any data coming, maybe your email cannot be labeled, messages, comments from social media can be categorized as unlabeled data. Text coming to your phone can be classified as an unstructured, unlabeled data as well. Yeah. Unsupervised machine learning involves training model using data that consists of features value without any known label. Unsupervised machine learning algorithms determine relationship between the features of the observation in the training data. Now, let's talk about clustering under unsupervised machine learning. The most common forms of unsupervised machine said is not working. Yeah. The most common form of unsupervised machine learning is clustering. A clustering algorithm identifies similarities between observations based on their features and group them into discrete clusters. For example, one, group similar flowers based on their size, number of leaves, and number of petals. Two, identify groups of similar customers based based on demographic attributes and purchasing behavior. In some ways, clustering is similar to multi-class classification in that it categorizes observation into discrete groups. The difference is that when using classification, you already know the class to which the observation in the training data belongs to. So the algorithm works by determining the relationship between the feature and the known classification label. In clustering, there is no previously known cluster label, and the algorithm groups the data observation based purely on similarity of features. In some cases, clustering is used to determine the set of classes that exist before training a classification model. For example, you might use clustering to segment your customers into groups and then analyze those groups to identify and categorize different classes of customers: high volume, low volume, frequent small purchase, and so on. You could then use your categorization to label the observation in your clustering result and use the label data to train a classification model that predicts to which customer category a new customer might belong. Now, um, clustering can be used maybe for a use case where you are trying to work on a market segmentation projects. You can use it to, you know, classify word groups. Can use it to classify if something belongs to a particular community. Yeah, you can actually use clustering uh, to determine that. Okay, we're going to look at some of the business use cases where unsupervised machine learning is being utilized or leveraged, most especially the clustering techniques. Okay, let's move to regression. Okay, regression. Regression models are trained to predict numeric label values based on training data that include both features and known label. The process for training a regression model, or indeed any supervised machine learning model, involves multiple iterations in which you use an appropriate algorithm, usually with some parameterized settings, to train a model, evaluate the model predictive performance, and refine the model by repeating the training process with different algorithms and parameters until you achieve an acceptable level of predictive accuracy. The diagram. The diagram shows four key elements of the training process for supervised machine learning models. One, split the training data randomly to create a data set which wish to train the model while holding back a subset of the data you use to validate the trained model. Now, we have this, you can do this by using the Pareto principle, where you use 80% of the data to train the model and use the 20% of the data to validate it. Yeah. That is why we have the trained data set and we have the test data set. The test data set, which is a 20%, will be used to validate it. Okay? To validate the trained model. Two, use an algorithm to fit the training data to a model. In the case of regression model, use a regression algorithm such as linear regression. Use the validation data you add back to test the mode by predicting labels for the feature. And lastly, compare the known actual label in the validation data set to the label that the model predicted. Then aggregate the difference between the predicted and actual label values to calculate a metric that indicates how accurately the model predicted for the validation data. Yeah, we are going to look at a use case where we're going to run a regression model, and I believe you guys will be able to have a clear understanding of how this actually work. Yeah. Okay. After each train validates and evaluate iteration, you can repeat the process with different algorithms and parameters until an acceptable evaluation metric is achieved. Okay, this brings us to the end of our AI Spotlight teaching series for today. Thank you so much. Please endeavor to share this profile, share the link, share it on LinkedIn, share it on YouTube, Facebook, and Twitch. And if you have any specific question, please do not hesitate to drop your comment or reach out, send me a DM directly. My name remains Henry Onole, your AI expert, your AI strategist, your AI futurist, and also your AI advisor. Thank you so much. Talk to you guys soon. I have an update for you guys. Once I get to my destination, I'll connect with you guys again. Thank you. Do have a great day, and I wish you a great week ahead. Bye.